Good morning, my dear children. Today we are going to discuss about modern periodic table. Let's move into modern periodic table. After Mendeleev, another scientist called Henry Moseley in 1913, he showed that the atomic number of an element is more important or fundamental property than its atomic mass. We know that Mendeleev classified or arranged the elements in order of increasing atomic masses. But in modern periodic table, the elements are arranged in the increasing order of atomic numbers. Now, what is an atomic number? Atomic number is the number of protons in an atom. Okay. So, based on this fact, he put forward a law which is called modern periodic law that states properties of elements are periodic functions of their atomic number. That means when we arrange the elements in the order of increasing atomic number, their properties will also become repetitive. So we will see or we will discuss more about that later. Let's move into the next one. Next slide. Alright, now here the elements in the periodic table can be classified into three classes. They are metals, metalloids and non-metals. For example, in this periodic table, you can see a green colored zigzag separation here which contain boron, silicon, germanium, arsenic, antimony, tellurium and polonium. They are metalloids. They are intermediate of metals and non-metals. At the same time, metalloids show some properties of metals and some properties of non-metals. That is why they are called semi-metals or metalloids. Okay. But just before the previous line, all these elements are metals except this hydrogen. Okay. All other elements are metals, and after the zigzag line, all other elements are non-metals. Okay. And you can see two rows below which are actually the extension of these two rows. They are also metals. Now elements of each class share certain basic properties. For example, elements in the metals class can conduct electricity, whereas elements in the non-metals class generally cannot conduct electricity. In periodic table shown here, elements are color coded to show their class. For example, we can say that the yellow and blue colored elements are non-metals, while green color elements are metalloids and all other elements are metals. And also, as you move from left to right across each row or each period, these rows are called periods, the element change from metals to metalloids to non-metals. So as we move from left to right, we can say they become first metals, then metalloids, then non-metals. Now let's discuss what are groups and periods in a periodic table. The horizontal rows, you can see the horizontal rows here, they are called periods. From left to right across a period, each element has one more proton than the element before it. There are 7 periods in a periodic table. 1, 2, 3, 4, 5, 6, 7 periods in a periodic table. You can see some periods are longer than others. For example, when you check the first period, see this is the first period. Okay, only contain 2 elements, hydrogen and helium. Okay. Now, when you reach the 6th period and also the 7th period, you can see they are so long that many of their elements are placed below the main part of the table. They are elements starting from lanthanum in period 6 and actinium in period 7. For some conveniences, they are placed below. Actually, they are the extensions of 6th and 7th period. Now we will move to the groups. The vertical columns are called groups as they are in the Mendeleev's periodic table. However, modern periodic table has many more groups. 18 groups compared to just 8 in Mendeleev's periodic table. Mendeleev's periodic table contained only 8 groups, while modern periodic table you can see 18 vertical columns are there. If you count like this, you can see 18. What is the 18th column? 18th group. They are noble gases: helium, neon, argon, krypton, xenon, radon, etc. Now one more fact you have to remember, you have to keep in your mind is, elements in the same group have similar properties. For example, all elements in group 18 are colorless, odorless gases such as neon, argon, krypton, xenon, etc. Another example is alkali metals. That is, all the elements in group 1 are very active solids. They react explosively with water. Lithium, sodium, potassium, rubidium, cesium and francium. Okay, they are called first group elements. They are also called alkali metals. So this is the second group: beryllium, magnesium, calcium, strontium, etc. They are called alkaline earth metals. And these all groups together, they are called transition elements. And the two rows shown below are also extension of this group. They are called inner transition elements. So this is transition elements, okay, and these are inner transition elements. Now there is no special name for 13, 14, 15, 16th group. They are called simply boron family, carbon family, nitrogen family and oxygen family. Okay, and the 17th group are called halogens: fluorine, chlorine, bromine, iodine, astatine, etc. are called halogens. And the last 18th group are called noble gases or inert gases. And all together 118 elements are there in the periodic table. Out of that, 92 elements are natural elements. Some examples of natural elements are hydrogen, oxygen, carbon, fluorine, etc. Some examples for artificial elements are polonium, fermium, curium, neptunium, technetium, etc. And the elements are represented by using their symbols. The symbol consists of 1 or 2 letters. The first letter of the symbol is always written in uppercase. For example, you can see capital H here, which indicates its hydrogen gas. And element is represented by 2 letters. The second letter is always written in lower case. For example, if you take helium, you can see H capital and E small letter. And also atomic numbers increase from left to right and from top to bottom in the periodic table. When you move from left to right in a period, atomic numbers increases. Also, when you move from top to bottom in a periodic table, atomic number increases. Hope you get an idea about modern periodic table, its structure, its classifications, what are groups, periods, etc. So next class we will start the trends in modern periodic table. To learn the trends in modern periodic table, having a clear idea about the structure of the periodic table is very important. Hope you understood it very clearly. So we will continue in the coming class. Thank you and have a nice day, and thank you for watching.